Math 3, Unit 5, Section E. Today we're talking about solving rational equations. So previously we were simplifying things, but we weren't actually solving for a variable. We have the steps here for solving rational equations. The one thing that you always need to be very careful about is your extraneous solutions. So before you start every problem, there are usually two things I like to do. Number one is find the LCD, and then number two, find all of the extraneous solutions. Okay, so on this problem, what would be my least common denominator?
On A.
On A, yes. X plus 2. Good. Because both of these denominators are x plus 2, so my denominator, my common denominator, would just be x plus 2. Now, if we were to set x plus 2 equal to 0, what would x equal? Negative 2. So that means that my extraneous solutions, and I'm just going to put that as ext, is that x cannot equal negative 2. Because if I get an answer of negative 2 for x, if I ended up getting negative 2 in the denominator, that would make a 0 in the denominator, which would not work. So far, so good? Okay. So then now, which we've done some of this stuff before, but in order to eliminate the fractions, we want to multiply everything by the LCD. So in this case, we'd multiply everything by x plus 2 so that we can eliminate our fractions. So when I multiply by x plus 2, these cancel and these cancel. Okay, and so we're left with x minus 1 equals x squared plus 2x minus 3. And so now we need to solve. Go ahead and grab the notes right there by the door. Yes?
Why did you put the x plus 2 next to the numerator and cancel the denominator?
So I'm eliminating the fractions.
Okay.
So we eliminate fractions by multiplying by our LCD, or our common denominator. And so there's really only two terms. There's this term right here, and this one right here. So when I multiply everything by x plus 2, it eliminates both those denominators.
Okay.
Okay? And so it's going to work out different on this one because this will have a different LCD. But you'll whatever our LCD is, we're going to write it next to every single term in the equation in order to eliminate your fractions. Okay? So to solve for this one, you always want your x squared to be positive. So which way would we move things? Serena, you getting all this stuff down? Okay. So what am I going to do? Good. We're going to move everything to the right, and so we are going to subtract x and add 1. And so I'm just going to line those up with their like terms. So those cancel. We get x squared plus x minus 2, and we can put equals 0 on either side. It doesn't matter. So now since I have an x squared term, we probably need to see if we can factor. So can I factor? Yeah. So this really is a 1 in front, right? So that is my adding number is 1, and my multiplying number is negative 2. So what multiplies to be negative 2 and adds to be positive 1? Good. X plus 2 and x minus 1. So that multiplies to be negative 2 and adds to be 1. And when we set those equal to 0, what do we get that x equals?
Negative 2 and 1.
Good. X equals a negative 2 and a positive 1. Okay, but if we check that with our extraneous solutions, what can x not equal? Negative 2. So that answer is out. That cannot be an answer because that would give me a 0 in the denominator, which is undefined. Therefore, my only answer is that x equals 1.
That's kind of what we did before.
Exactly. So you guys have kind of done this before. Okay. B.
Makes it a heck of a lot easier to check though.
It makes it easier to what?
Check.
Yeah. Okay, so B. Yeah, instead of having to plug everything back in.
Yeah.
All right, so again, the two things that we always want to start by finding are LCD and our extraneous solutions. So looking at this problem, what would be my LCD? X plus 4 and also x plus 1. We need both of them because remember pluses connect them like glue. If they're not exactly the same, they're not the same. So we need both of them in our denominators if we were finding the LCD. So x plus 1 and x plus 4. And so the purpose of finding those is that if we multiply every term by our LCD, we can eliminate all of the fractions. Okay? Looking here now, if we set each of these equal to 0, what can x not equal?
-4 or -1.
Good. -4 and -1. So we always have to check for those solutions at the end. Okay, so since my LCD is x plus 4 and x plus 1, I go to every single term and write x plus 4 and x plus 1. And then my fraction should end up eliminating. And if they don't, then I did something wrong. So there's multiple ways to do like this next step, but to keep myself organized, I normally will cancel out my denominator. And then I'm just gonna write for right now x times x plus 4, and then my next step I'll go through and multiply it. This way I don't end up hopefully messing up. On this next one, I have an x plus 4 that's eliminating, and so here I'm left with 3 times x plus 1 equals, and this last one, the x plus 4's cancel. On this one, when I write it, I'm multiplying x plus 3 times x plus 1. So be careful that you're not just like distributing the 3 through. You're multiplying both parentheses together. So when we go through here and distribute and multiply, this first one, we get x squared plus 4x. The next one, 3 times x is 3x. And 3 times 1 is 3. And then this last one, you would use your box method or FOIL, or if you can do this in your head. But when we multiply, I would get what?
X squared plus 4x plus 3.
Perfect. X squared plus 4x plus 3 is correct. So remember that these two numbers, you add them together to get your middle term, right? And we multiply them together to get our ending term. Okay, so we need to solve. You can start by simplifying each side. Your notes are right there. So we have x squared, 3x, and 4x make good. And then we have x squared plus 4x plus 3. What happens, so if I were to like subtract x squared to both sides, when you have the same thing on both sides and you end up subtracting it, what happens? They cancel out. So if you notice the same thing on both sides like that, you can just cancel it without even writing the minus x squared. Or if you want to go through that process, you can. So now that those have been eliminated, which way would you like to move things?
Well, could you also do the threes too?
Oh yeah, you could. So do you guys notice how these are both 3's? So those could also eliminate. So I really have 7x equals 4x. So what would you do next now?
You would subtract.
Or 4x. I'm going to subtract 4x. So when I subtract 4x, I end up getting 7x minus 4x, which is 3x, and 3x equals what? 0. And then in order to get rid of the 3, what would I do? Divide by 3. So those cancel out, and 0 divided by 3 is 0. So x equals 0. Is that one of my extraneous solutions? Nope. So that's my answer. Okay, problem C, I'm going to change this problem. This one, when we ended up solving it, you needed to use the quadratic formula, but you don't have anything on your test that's like that, so I'm changing it. Okay, so cross that out. The new problem is 5 over 2x minus 2 over 3, or 2/3, equals 1 over x plus 5 over 6. Serena, you're writing some of this down, right? Okay, you need to be doing this with us, okay? All right, so what would be my LCD on this problem? So, Well, close. So I always start with my largest number. So in this case, my largest number is what? 6. Can 2 evenly go into 6? Yes. Can 3 evenly go into 6? So 6 can be my number, and then I have my x's, and the highest exponent of the x's is just 1, right? So we really only need an x, because when I go through and multiply each term by 6x, it's going to eliminate my x's, and it will also eliminate my numbers. Now, if you used a larger number, that's fine. You're just going to have to reduce more at the end. Okay? Now, when I set this denominator equal to 0, what would I end up getting? What would x equal? 0. Is everybody okay with that? So if you're ever not sure, set your denominator equal to 0. And to get x by itself, I divide by 2, and so x equals 0. So what are my extraneous solutions? 0. So x cannot equal 0. So far, so good? Okay, so next thing, in order to eliminate our fractions, we're going to multiply everything by 6x. Okay, so when I do that, here the x's cancel, and then 2 goes into 6 3 times. So since I just have 2 numbers multiplying, I'm not going to write it all out. I'm just going to multiply 3 times 5, which is 15. Okay, the next one, 3 goes into 6 2 times. So we have a minus sign there in front, and then we have 2 times 2 is 4, and then we solve the x, so that's 4x. Equals, next one, the x's cancel, and then you have 1 times 6, which is 6, and then the 6's cancel, and we have 5 times x, which is 5x. Okay, any questions on that one? Okay, so now we're just going to finish solving. So we're going to move things around a little bit. So I like my x's to be positive if I can. And so I'm going to go ahead and add 4x to both sides. So we have 15 equals 6 plus 9x. And then next I would I'm going to subtract 6, right? Either way, however you did it, you did the opposite way, that's fine. And 15 minus 6 is 9, so we have 9 equals 9x. And then my last thing would be to divide by 9. And so x equals 1. And it's not an extraneous solution, so I'm good. What happens if my answer ends up matching my extraneous solution and it's the only answer I have?
No solution.
Good. Then it's no solution.
Oh, really? I was just joking.
Nope. You got it. Okay, any questions on C before we move on? All right, D. Okay, what is going to be my LCD?
1 minus 2x.
Good, LCD is 1 minus 2x, and my extraneous solutions on this one will be what? If you're ever not sure, what do you do? Just set it equal to 0. 1 minus 2x equals 0. And solve it. Close. Should be positive 1/2. So these, we get 1 equals 2x, right, when we're moving, and then we divide by 2. And so x cannot equal positive 1/2. All right, you think you guys can solve this one on your own? Good, I think so too. So, when you get your answer, raise your hand and I'll come check it. All done?
I think so too.
It's okay. Okay, everybody should be trying this problem. Some of you, I think, already forgot what you're supposed to be doing. so it should be a fraction. And I cannot find this positive, but I'm not certain that this way. That's what I got. Dang, Noah. Yes. Okay, so let's go ahead and walk through this one. My answer was a positive 3 over 11, so let's see if I did it right. Okay, so we're going to multiply every term by 1 minus 2x, correct? So we end up multiplying this side and then this side, 1 minus 2x.
Jesus.
Okay, so 1 minus 2x cancels out, and I'm left with x plus 2 equals, and then I'm going to just write this as 5 times 1 minus 2x. So here I have to distribute, and so I still have x plus 2 equals 5 times 1 is 5, and 5 times negative 2x is
Negative 10x.
negative 10x. Okay, you can move things either way. It's up to you. I normally like my x's to be positive. That's just me. You don't have to do it that way. So I'm going to add 10x to both sides. X plus 10x is, so I have 11x plus 2 equals 5. Next I would subtract 2. 11x equals 3. And then the last step is to divide by 11 to get x equals 3 over 11. If you had got a negative x, then you would have had a negative number, and then a negative divided by a negative makes a positive. So either way, you'll get the same answer. And does this match my extraneous solution? No, so I'm good. Okay, so if you didn't get that one correct, did we see where we went wrong? Okay. All right, let's go ahead and move on here. So just a couple more problems to kind of show you all the different types that you could end up seeing.
So much.
So LCD on this problem would be what?
3 over 6.
Close. So just, yeah, and you know what? I'd write it as 3 times n plus 2. Leave it factored because it will be easier to cancel out your denominators. And then if I were to set this denominator equal to 0, what would it equal? Negative 2, so that means that n cannot equal negative 2. This denominator doesn't have a variable in it, so we don't have to worry about it ever equaling 0. Okay, so what's my next step now?
You multiply the things by 3 and plus 2.
Good. Multiply each term by 3 times n plus 2. Okay, so on this one, what ends up happening?
Cancel out.
Good, they cancel out, and we're left with 3 times 1, which is 3. Good. Equals. The next one, the 3's cancel out. I'm going to write this one out, though. So I have n times n plus 2 left over. What will I do to solve this one?
Distribute.
Good. Distribute the n through. So I have 3 equals n times n is n squared. N times 2 is 2n. And what would I do next to solve this one?
Subtract 3.
Good. Subtract 3, so we get everything on the same side with our n squared being positive. So n squared plus 2n minus 3 equals 0. Bless you. So we are what adds to be 2 and multiplies to be negative 3.
2 and 1.
Oh, that's 3 and negative 1.
Good. N plus 3.
Oh, never mind.
And you're just doing the wrong number, like the 2 instead of the 3. And n minus 1, so those multiply to be a negative 3 and add to be positive 1. And when we set those equal to 0, what do we get?
Negative 3 and positive 1.
Yes, negative 3 and positive 1.
Got messed up.
So which one is?
And do any of these match with our extraneous solutions? No. Okay. F. LCD. What is the LCD on this one?
3x minus 1.
And also
3x.
Good, because anything that has a plus or minus is stuck together like glue. So this is completely different than this 3x.
We can't see it.
You can't see it?
No, like the entire
There you
Oh my goodness. Okay. Do we understand why it's 3x and 3x minus 1?
Yeah.
Okay. And so what are going to be the the extraneous solutions on this one?
Zero.
go. 0.
0 is one of them, because if we set 3x equal to 0, we divide by 3 to both sides.
0 and 1.
No,
1/3.
1/3. So again, if you're confused on that one, set this denominator to 0. 3x equals 0. To get x by itself, we would divide by 3. 0 divided by anything is 0.
Okay.
So that's where x cannot equal 0. This one, 3x minus 1 equals 0. Add 1 to both sides. 3x equals 1, divide by 3, and we get 1/3.
So you just like put equals 0 on all of them?
On each of the denominators. Because if your denominator ended up being 0, it makes it an undefined answer. Okay? All right, so what's our next step now?
Multiply everything by 3x times 3x minus 1.
Perfect. So every term, I'm writing 3x and 3x minus 1. So even if you don't have a fraction, you have to multiply every single term by that. Okay, the first one, what ends up happening? The first term. 3x's cancel out, and you have 1 times 3x minus 1, which is just 3x minus 1. Next one, the 3x minus 1's cancel out, and we have 3 times 3x, which is 9x. So we have minus 9x. What is 0 times anything?
0.
0. Okay, we combine like terms. You have a 3x and a negative 9x, which makes
6x. Wait, no, hold on. Negative 12x. This is 9. Negative 6. No, yeah.
Negative 6x.
this is not a trick question. It is negative 6x. Negative 6x minus 1 equals 0.
How can you guys not figure that out? I don't know. Why didn't you say anything?
Yeah.
I wasn't paying attention, but that's hecky easy. Even I
Okay.
knew that.
It's Monday morning.
Yeah, Mondays. All right, next, what will I do?
Frill.
Add 1 to both
There we go.
sides.
Negative 6x equals 1, and then the last step.
Divide each side by negative 6.
Thank you, good. Okay, so that means my answer is x equals negative 1/6. Did that match any of my extraneous solutions? Nope, so we're good to go. There's my answer.
Finishing that problem, it's like, no, you have to multiply it out.
All right, last one.
Why they critical mass?
Okay, so looking at this, what do you think that we should end up doing first?
Try.
Not doing it.
True.
Factor. Okay, crying was not the correct answer. Okay, so when I factor this, what multiplies to be a positive 15 and adds to be a negative 8?
Negative 3, negative 5.
Good. Okay, now, obviously this is the most complicated problem, okay? Is x minus 3 and 3 minus x the same?
No.
No,
Not yet.
not yet. What can I do to make it so that it is the same?
Take out a negative 1.
You take out a negative 1. Okay, so when I take out a negative 1 here, remember, it changes the 3 to a negative and the x to a
Positive.
positive. So now this is a negative 3 and a positive x, which matches with this, okay? This negative 1 here that's in front, I would move it up to the top.
So just negative.
So just make this a negative 1 up here, and then you can kind of like cancel out that negative 1 in the bottom. The negative can either go at the top or the bottom, and just so we don't even have to think about it, if we just move it up there to the top, it's fine. Okay, so what is my LCD then on this problem?
X minus 3 and x minus 5.
Good. And if we set our denominators equal to 0, what are my extraneous solutions?
5 and 3.
Positive 5 and positive 3. Okay, So this one, we get a positive 5, a positive 3. This one, I get a positive 5. This one, I get a positive 3. Okay. Are we good? All right. So next step, we are going to multiply every term by x minus 5 and x minus 3 to eliminate all the fractions. Correct? Okay. So I'm going to write next to every term. The reason why I take my time and do this every single problem is because I don't want to make any mistakes. And I find that if I write everything out each time, I don't make mistakes. But when I don't write it out, I do make mistakes.
But it's also, everybody makes mistakes.
That's right. But we don't want this class to make mistakes. I want everyone to be perfect.
I can start singing it even more noisily.
Okay. All right. So, first one, everything cancels out, right?
Yeah.
And what am I left with?
7x plus 3.
7x plus 3. Good job. Okay, next one, what happens?
Cancel out the 5.
X minus 5s. And this one, because there's a whole bunch more to multiply, I'm going to write that out as 3x times x minus 3, just to be safe, so that I don't mess up. Equals, and then here, the next one, what happens?
Negative 1 times.
Good. The x minus 3's cancel, and we have negative 1 times x minus 5. And again, I'm going to write it like that and distribute. Okay, so next we're going to get rid of our parentheses by distributing through. So I still have 7x plus 3, and then 3x times x is
3x squared.
good. And 3x times negative 3 is
Negative 9x.
good. Equals, we distribute through here, and I get a negative x and a
Positive 5.
positive 5. Okay, so right now this kind of looks a little bit like a mess. So we should write it in descending order and combine like terms. So I'm just going to start by simplifying this side. And so I'm going to start with 3x squared if I'm writing it in descending order. And then again, this is not a trick question, but I'm going to combine like terms. And so we have 7x and a negative 9x.
Negative 2x.
Good job.
Jesus Christ.
And then we have plus 3 equals negative x plus 5. Next, what will I do?
Add X, subtract 5.
Good. Add x and subtract 5. Cancel, cancel. And so we have 3x squared.
Minus X minus 2.
Good. Minus x and minus 2 equals 0. Okay. So since we have an x squared term, we're going to have to factor. How do I factor this?
You do the 3 and the negative 2.
Very good. So we're going to go 3 times negative 2, which makes a
Negative 6.
negative 6. And then we want it to add to be a negative 1. So what numbers will work for me there?
Negative 3 and positive 2.
Good. Negative 3 and positive 2. We all okay with that? Okay, so how do I end up writing it out over here?
3x squared minus 3x plus 2x minus.
Perfect. And then because I have 4 terms, I'm going to factor by grouping. Okay? And so my first group, what can I factor out?
3x.
Good. And I'm left with
X minus 1.
second group, I can take out a
2.
2 and I'm left with,
X minus 1.
right, x minus 1. And then that means that when this factors, it's going to be what?
3x plus 2 times X minus 1.
Good. 3x plus 2 times x minus 1. And when we set those equal to 0, what does x equal?
1 or negative 2/3.
Good. Negative 2/3 and a positive 1. And again, if that doesn't make sense to you, you can set those equal to 0 and you'll get those answers. Do any of these match with my extraneous solutions? Nope, so I'm good. Both of these are my answers. Okay, questions?